Hello and welcome to the Nova Show. I'm your host, Chris Nova. Welcome to the show. Here at the Nova Show, we do what I want when I want because it's my fucking show. Today on the Nova Show, we're giving my puppy treats. Dustin? Está bien. Francis will go there. He's such a good boy. So I'll lift him up here in a second. He's got to get his treats first. How's everybody doing today? Thank you for the follow, everyone. Welcome to the show. I'm your host, Chris Nova. Welcome in. Bien. Bien, bien. Oh, my little bear. Oh. So this is Björn, everyone. Happy Sunday. And welcome to the Nova Show. Let's see. You want to see the camera? The camera's right up. Can you see? Can you see? You want to tell the people hi? One of the reasons I love Björn so much is no matter how many bad people there are in the world, no matter how many angry people there are, I know Björn is he's just got such a simple heart. Thank you. Do you want to tell people hi? So just speak into the microphone and look at that camera and say hi.
Hi everyone.
Hello.
Good morning, afternoon, evening, whatever time it is over there.
Okay, bye.
Bye.
Cool. How's everybody doing? Welcome into the show. Cheeto Bandito is here. Hello, Cheeto Bandito. Welcome in. Welcome to the show. Hello, hello. So, here at the Nova Show, we fuck shit up. We have a lot we have to do today. The first thing we have to do today, we have homework we have to do for Nivenly, so we can maybe start there. Let me sit down and we'll jump into it. I hope you're all having a wonderful day. Let's tell our friends hello first. Oh, did I lose the internet? I think I might have just dropped for just a moment. Hopefully it comes back. We back? Okay. Let's see. So we have hello from Danielle. Thank you for the subscription. It's great to see you, Danielle. We have Coding is Weird, exactly 11 hours ahead here at Nairobi. Ghostface Killer is here. Good afternoon. Hey, Ghostface. Producer Wolf with a raid. Thank you for the raid. Producer Wolf says their stream was okay. Just chilling and making some music. That's one of the things I want to start doing more on my stream. I'm going to start composing music again soon. Just so I have music while I stream technology. BF Lund says, guys, what's the blue light thing in the back? That would be my delicious rack. I have a nice rack. Great question. Logic Coast 94 says hi. Cheeto Bandito says wow, hello. I am Root says hi. Nimjar gives Björn emoji and Logic Host 94. Shell Indigo says network drops. And Yoseek says I missed last stream. What is the Nginx analysis about? Good question. Good question. I'll answer that really quickly and we'll see what other people say. Pizza warmer, or so I've heard, says Maddock. Yes, my rack is also a pizza warmer. And is the rack in the background running Hackaderm? Kind of. Kind of. It changes. It changes often. So anyway, the Nginx analysis is this Nginx proxy analysis. Let me pull it up and I'll show you all what we have here. Nginx proxy analysis. Here it is. So here's the repo. I'll need to make a few changes to it. And then I'll share this in the chat, but it's just my GitHub. It's GitHub Nginx proxy analysis, and you can read more about it. But basically we want to just do some basic testing with Nginx and understand some failure modes of Nginx and reverse proxy buffering. So we started to work on this last time, and I think we're going to just try to iterate through and get some stronger conviction here, which will be helpful if you're interested. So, we are going to work on this, but before we do this, so this is, what we're basically doing is we're writing some C. Oh, and I need to get these binaries out of here. But we're writing some C, and we basically write some bad servers, and then we just run that up against Nginx, and we measure and see what happens on the system accordingly. So that's what we're doing here, and so we'll continue to keep iterating through this repo today. And it's a very niche thing. It's like, if you happen to be running a reverse proxy, what is Nginx doing? What does it do in these conditions with Unix domain sockets and so forth? So it's very, very like specific, which like makes for a good research project. It makes for a difficult discussion at times, but for right now, this is where we are. So anyway, we'll be looking at this. So what I want to solve first, we have a couple of things we need to do. So the first thing we need to do is so here we have a question, and this is a question for everybody out here watching, because you all might know something I don't know. The question is, how do I get the dry shampoo to not make my hair look gray? No, I'm just kidding. That's just, I know how to do that. It just involves taking a shower, but fuck that. Anyway, the question I actually have is, does anybody know, does anybody have an opinion, internet, on like an open source calendar style tool? So we need mailing lists, we need a calendar, we need people in the open source project to be able to view and edit and interact with these different services. And we ideally don't want it to be managed on like a large public cloud. So like we could use Google Groups for this, for instance, but I'm trying to find something that's like not Googly, if that makes sense. And so I know that, you know, we have decentralized technology Mastodon that we self-host. Do we also want to set up like a decentralized calendar mailing list service? And if so, what are the good ones? Who has an opinion? Tell me what you got. That's what we're looking at today. That's the thesis for the first like 10 or 15 minutes here. So anyway, hopefully, I'm imagining all of you are like going and researching right now, and then you'll tell me what you end up finding, and I'll kind of do my own research with my cute little whatever this, I don't even know what this is, Froggy Friends, whatever Froggy Friends is here. So anyway, we're basically going to be looking into like open source, well actually let's just say decentralized calendar. Good. ca.gov, off to a good start. Of course, nothing is here. This is the decentralized calendar. Semantic Scholar. So let's do decentralized mailing list, I guess. Let's do open source mailing list calendar. Listmonk, free and open source self-hosted newsletter. This is on GitHub. And what does this do? ChatGPT says Nextcloud might have what we need. There you go. Let's go see. Nextcloud. What is Nextcloud? Online collaboration platform. Fascinating. Region control over your data. Remote collaboration made easy. On-premises or cloud. Customizable or scalable. No data leaks to third parties. Try Nextcloud now. Huh. Solutions, government, enterprises, education, pricing, products. Nextcloud, calendar, contacts, and mail. Can be self-hosted. Ooh. Ooh, I think this is exactly what we're looking for. This is precisely what we're looking for. Thanks, ChatGPT, for being smarter than we are. Not terrifying at all. Oh. Now, if we set this up, let's just go and see. Cool. And let's do a yay SYU. So we're gonna upgrade. And actually, before we do this, hold on. We're gonna do yay SS Nextcloud. See what we get. There you go. We have all of this. Been running Nextcloud for some years now. Pretty neat. Started as a Dropbox replacement. It's all PHP if I recall correctly. That gives me absolutely no comfort whatsoever. GitHub integration into Nextcloud. So these are all in the Arch user repos. Social sharing email. Enable direct sharing of files via email. Promote Prometheus exporter. Fascinating. So here it is. There's next pass. There's Nextcloud maintenance. Let's get this turned on. Let's get this set up really quick. What do y'all think? Do you think we can set this up in like the next 15 minutes? Let's do it. Also has support for Federation. Even if PHP, it's quite stable. Okay, so let's system cuddle list units grep next. How do you start it? Hey everyone, this is Arjunberry. Hey Arjun, welcome to the show. Try Nextcloud groupware. How to get started? Self-hosted Nextcloud. Here you go. Download server. Read the docs. Users, admins. Here we go. Installation and server configuration. Server. Oh, that's system requirements. Installation on Linux. Here we go. Lamp stack. Oh, we need to set up a whole lamp stack. So yeah, this looks a little too... You have to start Apache, and I bet there is varlib Nextcloud. Yep. I bet there's, yep, apps. I bet it's right here. Yeah. Okay. I don't think we're gonna set it up today, but this is a thing that I think we should set up. And now the question is, can we get it set up in a cloud somewhere and then like move it? In our live demo for mission critical use. Let's see what the enterprise solution is. Security, expertise, influence, functionality. Oh, there's monitoring. It's IT stays in control. Start at Ionis. What's Ionis? Anybody know what that is? It's a web provider, Germany in 1988. Interesting. Find another provider. Technology providers. So TrueNAS, Red Hat, solution providers, Fujitsu, Docker. Yeah, we could manage it. I thought Hetzner was Germany's biggest provider. Danny Soft. Okay. So yeah, we could set it up with Kubernoodles in Docker. Okay, cool. So we're not going to do this today. I think we found what we're looking for though. We found our solution, which is the right way to go. Okay. Subchris is Tiberius. Hey, what's up, Tiberius? Okay. So we've at least identified our technology, which is Nextcloud. Now it's just a matter of getting it set up, which I'm sure we'll do another stream on that in the future. We know that it's a LAMP stack and we have to manage the Apache server and everything to make it happen. Now, let's talk turkey with this Nginx proxy analysis. What do y'all think? Who wants to write some C and do some Nginx analysis? I know I want to write some C and do some Nginx analysis. Where did I check it out to? What's in mount? And let's move unify to, let's make der archive. No, let's make der, yeah, we'll do archive and we'll move unify into archive. Cool, so there's that, and we have this, and let's go to source, and let's RM, RF, everything. And actually, I guess we can keep that for now. Sudo RM, RF, everything. There we go, and we will git clone git at github.com. Chris Nova / Nginx proxy analysis.get. I thought I had this checked out here already, but I guess I nuked it, which means I also lost my makefile, which we can rewrite my makefile. Maybe, is it in GitHub? No. Is it in books? No. Etsy picture source. Is it in temp? No. Cool. And we'll git pull origin main. There we go. And we'll go into source, Nginx proxy analysis. Here we go. And we're gonna have to, oh, there is a makefile. It is there. Okay, cool. So let's get into it. Let's go run our tests and see where we are. Hopefully I saved everything. Nginx proxy analysis. Opening now in CLion is the text editor I use. I use CLion. We'll cancel that. We'll close that. And we'll zoom in so you guys can see. There you go. And so we were going to remove some of these binaries from here. Git status, git save. Okay, so the binaries are removed. And our makefile is here, and this makefile is here. Very good. And cases and Etsy. Yep, we're still good. And we have our C. And we have our run cases. This is where we were getting into some trouble yesterday. Cool. Or Friday when we were working on this. Cool. They are quite popular around here. Awesome. I'm excited to learn more about Nextcloud. I will be definitely getting into it. We're going to take a quick breather. I'm going to go grab a cup of coffee, and then we're going to get into this Nginx analysis. I'll see everyone in about 3 minutes. We'll see you in a second. Okay, and we're back. Thanks for being patient with me, everyone. Okay, so let's run some tests. So we have run cases. Let's put a quick check-in for run cases. Good old EUID here. Cool. So we'll actually say this. I know, I want really clean output when I do this. There we go. There it is. Okay. Permission denied. Perfect. Cool. Cool. So here we go. So basically what we did is, so here we started our WebSocket case, happy launching upstream server, basic socket Nginx. This is our happy server. Ah, no such file or host. So let's do a set E. So it will break again. This should break. Make sure. Nope. Why didn't it break? Starting upstream. So this was here in our case. Ah, yes. Set E. Basically bash on expert mode. No, you should still be breaking. So this is line 4. Source upstream basic server. And I guess really what we can do is just this. Let's get rid of these cases. Right? Yeah. So upstream case. Memory usage hasn't changed. No, it hasn't. So basically we will replace this line with just this. And just this. File is equal to source Upstream basic server TCP. If else so this will be make sure this works. Cool, missing executable. Perfect. And then if we do make upstream, let's make sure that this works. Make upstream. There we go. And we run our test again, and now it should. There we go. Great. Cool. So we'll stop our test. Cool. So remove this. We want to get rid of that output. Cool. So parsing WebSocket server. So that's dashboard. Where are you at? So how do we do go access in silent mode? Let's see. So we can just log here. Bar log Nginx proxy. Cool. So that should help a little bit more. Cool. And we are sending 1,000 requests to localhost, and our memory stayed the same, which we're not super confident on this memory check. And in fact, we can let's get rid of this really quick. And the proxy server is there. Upstream case, so we'll get rid of stats and we'll just do traffic here. Oh. And then for traffic, there we go. So we'll run this again. Okay, so this is the happy path. So we should have basically sent 1,000 requests to a working configured Nginx proxy there. So let's go check and make sure. So what we want to do is we want to pull up our report.html. So there we go, 10,000 requests. And let's check the state of the file system. Nothing's going, and grep Nginx, and it's pretty straightforward. Okay. Okay, so now we press any key to continue, and we killed our basic server, and we were basically creating a bad server on localhost port 80. And let's go. We should see 20,000 requests now. I guess, did it clear the dashboard? Let's go see. See what it did. See if it cleared our logs. Here's our sad path. No, it did not. The only time we clear the logs is here. So how come we did not see... Oh, I know why. I know why we didn't see this. This is fascinating. Okay, this makes sense. So what just happened was... we basically... Oh, sorry, hold on. Nginx is still running. PSOX grep Nginx. Ekill F Nginx. Here we go. So Nginx was running. Our server should be down, or it's there, but there's just no data for it. So what ended up happening? Sorry, I know I'm going fast. I was just trying to kind of get my brain re-downloaded. So what we did is we sent 10,000 requests through a working Nginx proxy. Okay. And that result on the back end and our little... Interesting. Did Twitch just hiccup for you all? My internet just blipped for me for Twitch. Did y'all just see a similar outage there on your end for Twitch? So we'll see. Yep, people are saying yes. Okay. So no worries. So basically, and thank you for the follow, Coca-Cola 71282. Welcome to the Nova Show. I hope you love it here. So basically, if we do, let me reset. If we do sudo e run cases, sorry, source Nginx, sudo e run cases. If we run this again, which I stopped it, but if we run that again, we will send 10,000 requests and have them work, and then we send 10,000 requests and the server looks like this. So we have our bad server unix.c. Okay. So this is basically, it just does nothing. It doesn't even accept the requests. So that's where we are there. So, what I'm curious about in this is the state of the Unix sockets. Let's go take a look. So let's actually just run source upstream bad. PSOX grep upstream. Oh, pkill f upstream. There you go. Really? So how is sudo e netstat? So what's listening on port 80? 8080 22. Anybody who's ever pen tested something before is looking at this going, oh. I think why does it think 80 is in use? Oh, I know why. Sudo e. That's why. That's just a bad error message. So where's already in use? I guess it doesn't matter. So the server's running now. So let's go take a look in proc. Or sorry, let's go to dev. One second. So we can do this. Yes, ox, grep, bad. There we go. So what we want to do is we're going to go to upstream bad server Unix. Here's our PID. And let's actually add this to our run cases just so we have it. Actually, we'll do this. Upstream basic server Unix. And we'll say PID. Is, what is it? Question mark 1? No. I think it's just that. Bash PID of previous command. Yep, it's just that. Okay, cool. We'll do this and we'll bring you out to here for good measure. And we'll bring you out here for good measure. And there you go. And we'll do the same here. And you're just gonna be... Cool. So we have our PID now, and let's go to proc the PID and sudo e bash, and let's go to file descriptor there. So we can stat the socket itself. Really what I want to figure out is the socket states and where the socket is. So let's do this. So it's var run and stat nginx proxy sock. Here we go. So this is the socket itself. Pseudo terminals, and then 3 read link 3. Here's our socket here. So we can also go to procnet, and in here we also see, sorry, I'm just trying to kind of remind myself, cat Unix. Here we go. Cat Unix grep. Let's see. There it is. Cool. So the question is, how do we translate this data here to socket statuses? So let's cat Unix type to hexel. Mm-hmm. Mittens the Killer Bunny says, dumb question time. Why are you exploring buffering / why would you buffer instead of a proxy direct to the client for like an L7 inspection? So that's what we're trying to understand, right? We're basically trying to understand what Nginx will do given the state of the server, right? And the reason for this is because we actually aren't totally sure how much and under what conditions Nginx will buffer. Right, so like in the first experiment where we did this bad server here, if you go and you look at bad server unix.c, we don't even call accept, right? We start the server, right? But when somebody tries to connect to us, usually they'll call connect. Or it's, wait, what do they call? Not connect. Actually, I think it is connect. They'll call connect, and then it waits for us to call accept. Okay, and if we don't never call accept, that connection just hangs. So that one was easy. We all kind of knew what that one was going to do. But I feel like that is a good example of where the Unix domain socket is here, but we never call accept, so we never actually create a file descriptor for that connection. You with me so far? And so what is the behavior? What does Nginx do? Does it release the connection? Does it time out? Who knows, right? These are all open questions. We're actually not super sure of what happens in these, which is the point of this little research lab that I'm doing. Hopefully that answers your question, Mittens. Unsure if that answers your question. Okay. So this, let's understand what these fields are. Let's do this. Cat Unix piped ahead. There we go. Cool. And let's pull up the man page for procnet Unix. And then there we go. Cool. So here's the man page for us, and we can turn on dark mode here. And we can also look at it here if we want. Man proc, and then we search basically for net Unix. Wait, which man page am I in? Either way, we can read here. Cool. So we'll link this in our research. Resources. Just woke up feeling like violence in Nginx today. Yep, that's my story and I'm sticking with it. Okay, so we'll get that resource documented. And list the Unix domain sockets present within the system and their status. The format is this. So really what we're looking for is, what is ST? The internal state of the socket. Here we go. So we want to grab this data here. So what do the numbers mean is the question. So let's Mm-hmm. Let's pull up the kernel source for AF Unix, I believe. Let's go see what we're using here. Basic server. So we're using ARPA inet sysun.h. So Sockets API. There's send, receive, ancillary messages, ioctls, errors, versions, example. We want the socket state in Linux. Let's go look here. Short of browsing Linux, I guess we can look on GitHub. We'll go look at the Linux source on GitHub. That's usually how I do it. Here, you know what? Let's actually, just while we're here. Where's the Linux? I always forget the name of the Git server. Not kernel.org. What is this Linux tree? Where's the Git repo at? I always forget where it's at. That's the spirit. Here, y'all can watch me while I look for this. Is it kernel.org? I feel like it's not kernel. Maybe it is. Is it kernel.org? Latest release. Git.kernel.org. Here it is. This is what I'm looking for. Thank you. Okay, so let's clone Linux. Where do we want to put it in source? Git clone. We want kernel get. Here you go. Tag. Here's the one that we're checking out here. Okay. Master branch. Git clone kernel.org. Here it is. Okay, so we'll let that run in the background, and this way we can actually explore it locally and we can check out tags as needed, because otherwise my system's going to try to find the current version that I have running right now, and that's not what we want. We actually want to be able to look through it for different versions. Okay, so there's Nginx proxy analysis. So let's, in the meantime, while that downloads, github.com Torvalds Linux. So we want to go to tags. We'll go to 6.2 and we're going to look in we're going to look in net. Remember, we're trying to find the states of the Unix domain sockets. We're going to look in net Unix address family Unix.c. And it might be in the header. Datagram sockets. This is the implementation. Let's look in Unix bpf.c. Is this source control management? What is scm.h? Nothing. Okay. We'll go here and see what we get. There's TCP states. Unix state lock. Socket state. State. So this is Unix release socket. So you can see it'll basically, it locks it and does. Fascinating. So Unix uses TCP close? That seems wrong. I guess you can send TCP over a Unix domain socket, am I right? Okay, Unix state lock. Oh, hold on. I just saw it. It was under bar connected. Unix state lock. Unlock. TCP states. Here we go. Socket state. Unix state lock. We've already looked. This is the release socket. Fucking semaphores all the live long day. Here we go. Unix create. Found it. README. Cool. So we're looking for the socket state unconnected here. Where are these defined in the source code? Believe it or not, BSD has address family Unix sock raw, though no scene uses it. Today I learned. That's a great post there. Today I learned that BSDs have AF Unix and sock raw. Okay. So let's find where this SS unconnected is from. Van Kluver says also, hi folks, just got back from a long walk with the doggo and gonna have a sandwich and maybe nap on the couch. Awesome. Cool. So let's go look now at what are we doing? We're looking for SS connected. Here it is. Include user API Linux net.h. Include user API Linux net.h. These header files, I swear to God. I don't care. And I don't care how many people in the world I've talked to who are like, let me put it this way. When people first come to Linux, they're often like, how does the file system work? When you go to root, you see you have, home and etc and boot and dev and, all these different things do different things, right? What is var and user and everything? And everybody freaks out about that, right? And then you get into the kernel code and it's that times 1,000. There's, how many fucking libs and kernel directories there are in the kernel source tree? There's like at least 100 of them, right? Just called kernel. And you're like, okay, cool. Let's just go see what's in this one, right? Like and then there's UAPI, and then there's Arch86, and then, X86, and this one's for modules, and this is where the module archives go, and this is where the linker files go, and this is where the objects go. And then when we compile the object, we have to make it an fucking kernel object, and that just adds 4 bytes to the beginning. But that has to go in a completely different directory because reasons, right? And it's just like, it's just such a pain in the butt. And I've heard people be like, no, you have to just, like, they come up with rhymes. They're like, the include directory is this and the UAPI is that. And I don't care how many fucking rhymes or easy to remember whatever, or maps or diagrams or cheat sheets there are in the world. I will literally never be able to commit into my memory the fucking, no, I can commit the tree itself. I can't commit the reasoning behind it. I have no idea why the tree is shaped the way it is. I don't think anybody does, and I'm kind of okay with that. End rant. Anyway, good old net.h here, if we can find it. IPH, no. Mroute, no. This is a funny one, mroute 66. That's what I call it in my brain. I know it's mroute 6 because of IPv6, but in my brain, it's route 66. Anyway, here are our socket states. Good old linux.net.h. So just as an FYI for people working in the tree for the first time, everything in UAPI, that's what you and I reference when we write C. Stands for user API. That's the code we vendor. So when in my code, when I do things like include, like if I was to do include linux/net.h, nothing's using it right now. Or sorry, Linux net.h, nothing's using it right now, which is why it's grayed out here. This is the user API. I'm the user. Okay, so here are all the socket conditions, socket states, and even then there's Linux socket.h. This is just net.h. Okay, so we have, these are socket states. It's a typedef enum, and here we go. Another thing to keep in mind is when you do an enum like this, SS free is 0, but unconnected is 1, connecting is 2, connected is 3, and disconnected is 4. It auto increments. So we're actually going to build a small table here while we wait for Linux to check out. And I need to close some of these fucking things. Okay, so we can close this one. We can move that over there. And we'll move this over there. Cool. So let's get a table put into my README here. So this will be C, and there you go. And actually, I don't need to comment this. I'll just do taken from here. And that's 6.2. There you go. Can y'all believe we're on 6.2 already? I just feel like it was just the other day we got 5.0. I remember it like it was yesterday. Works on ARM, a whole new fucking architecture in the past few years. Type def enum ss free. Okay, so these are auto incremented. Thank you for the follow, everyone. Welcome in. Welcome to the show. I'm your host, Chris Nova. Welcome to the show. Here at the Nova Show, we do what I want when I want because it's my fucking show. Today on the Nova Show, we are looking at socket states in the kernel and making sure our math lines up. Okay. And we're going to try to replicate these states as well. So let's, I think 2.6 was just a few years back. Yep. Who remembers BKL? Pop quiz. Who can tell me what BKL is? BKL. BKL. Who can tell me what BKL? No Googling. I want to know who's actually in here, who's actually old as shit like I am. You can tell why because of my gray hair. Okay, so we have bad server Unix, and let's put together our table. Let's see here. Who knows what BKL is? Basic kangaroo language. Good guess. Super good guess. Okay, so we'll do file, new table. So we want 1, 2, 3, 4, 5 rows. Or sorry, we want it to go vertical. So we want 3 rows and 6 columns. Nope, I did that backwards. New table. We want 6 rows and 3 columns. There we go. So we'll make this really quick. And so we'll generate, and so here it's going to be enum value, or so we'll call it enum value example, and we'll say sample enum ss free is equal to 0, and then a proc sample at procnet Unix there you go. Cool. So we had SS free. We'll do SS unconnected next. SSS connecting. You know, you think they would have picked a better name for these socket states. This is the same reason we don't have stateful sets in Kubernetes anymore. Or no, we have stateful sets. We used to not have, we used to call them, you know how there's the aliases in Kubernetes, like PO is short for pod. This is why you can't kubectl get SS. You have to do STS. Because throwing around the SS acronym is not always the best idea. Okay, generate. Copy to clipboard. There we go. Cool, and let's see how this looks. Lovely. Quite good. Okay, cool. So now let's run some experimentations. So we will get our socket state. Let's get, I use SS instead of netstat. I hear you. Okay, we're gonna write some bash when I get back. Quick break. We'll see everyone in just a second. We're back. We're back. Okay, so we're gonna do some quick analysis. So let's do the big line here. Also, I love this song, don't you? So we have these basic little tests we can kind of copy here. We'll put 2 lines in between all of this. 2 empty lines. There we go. Okay, so we have our test there. So we're gonna do our happy path, and we can do a traffic. Right, I guess I can write a function up here. Function will be, we could do socket state by socket. I guess it's always gonna be the same socket, right? We use the same socket for all of our tests. So let's just do this. Oh, I'm not knowing BKL that I'm old after all. Can you tell us the BKL story? Yeah. So good question. Big kernel lock. The big kernel lock. So when I had originally started working on Aura, I had put these slides together. And I'll just give you all a little bit of an overview. So these slides talk about the origins of Linux and distributed systems. And you probably believe that Linux works well in the enterprise, or at least works well for distributed systems. Well, it doesn't. It actually is designed for a single machine or a single user. And that's true. And then you go back and you learn about the computer science and blah, 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 in the history. And then what we're getting at here is sort of the 2 differences between like horizontal scaling and vertical scaling. Or vertical scaling is just scaling up to a bigger computer, and horizontal scaling is scaling out into more computers, right? So that's actually my favorite slide so far. Anyway, we talk about like all of these different implementations of distributed systems that you see around the world. You know, HTC Condor, AT&T Bell Labs did Plan 9, Kubernetes, Sun did some stuff here, Mesos, the IBM mainframe itself. There's just a lot of like cluster computing out there. And we talk about, this is where the big kernel lock comes in. We talk about how distributed systems have grown. And as it turns out, originally in like Linux 2.0, or 2.6 and before, we actually had to solve the problem of how do we distribute work across multiple cores. And we made that effectively transparent to the user, right? And so the big kernel lock was when we only had a single core. So everything in the kernel would lock at a moment, and you could break your system because you only had one core at the time. So actually the first distributed systems really came out here right after Linux 2.0 in 1996, when we had the SMP symmetric multiprocessor. And then we got full multi-core functionality closer to 2003. And it gives you like, this is right around the time MySpace was coming out, to give you like some idea of like how technology was doing at the time. So anyway, I put together a talk where I talked about all of this stuff and why Aura is the way it is, but it's never really seen the light of day. And so anyway, we're kind of back here. And so anyway, there's a lot of like, you know, assumptions that we made and, you know, what we did and blah, blah, blah. So I have yet to give that talk. I've never given that talk before. So So anyway, let's go back to our cases here. So what we want to do is we actually want to get the state of our Unix domain socket. So let's cat Unix grep or proxy. Okay. So let's now sudo e upstream Nginx source sudo e upstream bad server. Okay, so that's running and cool. So fascinatingly enough, we have this value here that I have highlighted. So that's 001, which according to our research we just did, it's an unconnected state. So stock it's state 1, it's an unconnected. So now let's do our upstream basic server Unix. And we go here. It's still in socket state 1. And if we, let's see, cat Unix grep proxy. If we curl it, I wonder what socket state it's going to be in. Upstream basic server Unix. Ah, I see why. Okay, so let's actually cat Unix grep proc. This is going to be interesting to get. Okay, so we will do for every request, we're going to do this. We'll say state is equal to cat proc net Unix grep for Nginx proxy analysis. Let's make sure this works really quick. As a root. Okay, and let's start a server and go and do it again. There we go. And then we want to pipe to cut delimiter space field 7 5. There it is. Cool. Grab that. Put you in right here. And we'll make just a little cheat sheet. Okay, so let's run our tests now. And we should see a bunch of numbers in our traffic. And let's just see what we get. Run cases. Cool. Fascinating. So we're seeing a lot of ones. In fact, I'm not seeing anything in here other than a 1. I feel like that checks with all y'all. I feel like I can just get lost in these patterns. Anyway, so that is socket state 1, and frankly, we're waiting on the kernel at this point. Cool. And I think we're very much ps-ox grep curl. What is our code doing? Do we run the curl in the background? We do, yeah. So we've already launched all of these curls. I feel like it was nice to learn about BKL. Yeah, and let's do 100. Let's just dial this back. Okay, let's try this again. This time with 100. Ooh, excuse me. And we're not really seeing anything else in here. And let's try it again. And we still see ones everywhere. Yeah, I'm not convinced we're actually seeing very much happen here. So the other thing that we could do is I want to know where all of this is coming from. Press any key to continue. Okay. So why does our socket state... Oh, interesting. I see. So we have a lot of Unix domain socket entries open here. Yes, aux, grep, Nginx. So Nginx is still running even though our cases stopped. And it's still there. ps-ox grep curl. ps-ox grep Nginx. Grep bat upstream. There we go. It's still running. pkill f upstream. And then now let's check our... There we go. So there was a bogus upstream server outstanding on the file system. That's why. So let's go to our run cases. And let's run them again. Sudo e run cases. Here we go. Perfect. So this looks like a lot more like what we want to see. And then press any key to continue. And then so here, this is fascinating. So now we've actually created multiple socket entries here. This is fascinating. Cool. So here we have basically created... Let's go read the proc man page and see what this says. So this says, list the Unix domain sockets present within the system and their status. The format is... The fields are, the kernel table slot number is num. The number of users of the socket is ref count. Oh. 3 users. protocol currently always 0. Flags holding the status of the socket. Those are always 0s. Type, sock stream, sock dgram, and sock sequence. So that's another enum we could go look up here. Type. This is 01 for sock dgram. It is 02, and for sock it is 05. State is the internal state. Okay, so we're actually looking for this. That's why we're looking at this value. We were looking at the wrong value. Fascinating. See here, there is discrepancies here. Good. Okay, good. We have actual data worth measuring. I was getting nervous for a second. Let's go update our README and let's fix our incorrect assumption. So this is all fine, except for it's gonna look like this. Cool. So our state is, where's traffic? So it is actually cut the next field over, if I'm not mistaken, 6. Yeah, so we were getting this one, we want this one. So let's run it again with a cut 6. Cool, so we should see, whoop, hold on. PS aux grep upstream. And let's go to our run cases. Okay, let's try this again. Run cases, and we should see happy output here. Oh, it kills itself, of course. Mm-hmm. Wait, what? Yeah, but what I see is clipped, but your face cam in chat, but I was wondering if you were looking at the right field. Cool. So we can get rid of this. And this. And let's run it again. Ah! Yes, ox. Grab upstream. Yeah, I don't understand what you're asking, Maddock. That sentence you typed doesn't really make sense to me right now. You kill upstream. Sudo e run cases. Let's run it. Socket already in use. I'm intruding, crawls back under rock. Yeah, if you have a question, please just... Nginx is running, that's why. kill-9 Nginx. So let's do this. pkill-f. There we go. Finally. Okay. There's our socket states there for the happy pass, and then we run them for... There we go. Fuck yeah. Okay, cool. This is great. This is honestly great to know. Okay. So we're still seeing some socket states in one. Okay, so let's write up some reports here. Findings. No upstream. Okay, so we'll say case we'll say number 1 is multiple lines in the procnet Unix file indicating multiple sockets opened on the same socket file. So what else did we find? Was that we'll say Nginx hangs and so this is server not accepting clients. Nginx hangs and clients also hang. Actually, how do we want to say this? Clients are synchronously hanging. Okay. Say upstream server not accept in clients. There you go. That's actually the proper way of framing this, where the upstream server does not call the C function except after a socket has... Here are the findings. Multiple lines. Each line in the procnet Unix file is in state 01. Actually, we'll say this. The socket state saturation from the procnet Unix file is roughly, let's get an idea. I would say this is 90%. 99%. I mean, we can actually do the math here. Let's grab all of these. There should only be 100, so we'll actually... Oh my god, come on, Nova Pants. How many 2s did we get? That's actually not going to be relevant. Is the vast majority, we'll say 90% or higher, in state O2 or SS connecting. With the minority in state O1, SS unconnected. Okay, so there's a case. Upstream server not accepting connections. Cool. So that one is good. Get status. We'll say git add everything. And then we'll do a git save. Okay. Okay, so there is that. And so now let's write a new server. Okay. And actually what I want to do is I want to do a big find and replace. So this will be bad server Unix, and we're going to replace this with we said refactor, rename. This is going to be server not accept Unix. And our make file here will basically be upstream server not accept. And here in our run cases, we will get rid of these lines. And here in our run cases, where did you? Server not accept Unix. Beautiful. Great. Okay. Let's get, where's our, here's this one again. Let's run it again. Makes basic server unix.c. Oh, okay, here we go. Server. So we did server not accept Unix. Which one is this? No, this one isn't accept. God damn it. Sorry. We have to undo my renaming here. Here we go. So let's try this again. Bad server Unix. Basic server TCP, basic server, server not accept Unix, upstream server not accept Unix. Refactor, rename. Here we go. Okay. then run cases. There we go. There's 1, there's 2, and then there's 3. And then let's ps aux rep Nginx. Okay, so we're not killing Nginx at the end. Run cases. Ah, this kills it. I see. Upstream basic server. One second. I'll be right back. I'm going to take a quick break. Okay, let's get this cleaned up a little bit. So we'll say label is equal to. That doesn't kill the root process, but we can try and see. Let's run it again. I need a key to continue. Yeah, so we're basically, I guess we got the PID here, so we can just kill that. So we'll do this. And we will say key, we'll say case PID is equal to this. And we'll just say kill -9. Stream cut out. Yeah, I don't know if that's my internet or Twitch. Y'all want to check and see if Twitch is acting up for anybody else today? It could be our internet. I don't know. Does anybody want to go and just look up Twitch and give us a report back in the chat here? You certainly can. You certainly can. Line 74. Ah. There we go. Cool. So we have case PID now. So now we can do ps aux grep Nginx app upstream. And what was the other one? Grep. Cool. So this should work. So we should be able to run this and keep running it. Beautiful. So upstream basic you PID this, press any key to continue, and then we run that, and then it closes all of this and exits. Okay, cool. So we actually have a solid test suite now, which is good. And for our traffic, Run it again. Cool. Okay, so let's build another case, shall we? So in this example, we're going to copy our server not accept Unix, and we'll call it server accept and not respond. Let's look at, what do we do here? So we accept not read is what we want to call it. Let's do this. Refactor, rename, we'll say server accept not read. Okay. So what we want to do is, where is our basic server unix.c? So here we do an accept, and we'll bring all of this into our server accept not read for loop here. Okay, so this will accept, and that's it. That's it. That's all it's gonna do. Okay, and let's go to our make file, and we'll basically do that, and we'll say server accept not read Unix. Cool. And then we'll add a new test case. Now this one's going to be exciting. This one's going to be exciting. Does not call accept. Server create socket. Call accept. But does not call read. Okay, so this is upstream. Accept not read. Am I right? That's what we called it? Yep. Unix. Okay. And this should give us our socket states here as well. Let's go take a look. Cases. Okay, so happy paths, 100 requests. Sad path, 100 bogus requests with accept. And again, oh, hold on. Let's do this. Make upstream. Cool. And let's just, for good measure, cat plot net Nginx grep analysis. Okay, let's run it again with our binary. 100 happy, 100 accept, or 100 no accept, and then 100 accept no read. Okay. No, it still didn't work. Source upstream accept not read Unix is not there. Upstream Oh, server except not read Unix. Okay, it's in my make file. Oh, it is upstream. Okay, so we have a lot. Delete this one and then delete these and make upstream and run our cases. Okay. Server works as expected, always returns HTTP 200. So we did get... We'll have to record this. In fact, I'll do it now before I forget it. I want to record our data here. So readme.md case... I believe we write back to the socket. I want to make sure that that is right. Yeah. And we close the file descriptor, right? Yeah. Mm-hmm. Oh, we're getting rated by Scott. Hey, Scott, how's it going? Cool. So readme here. In the case where the upstream server worked as... We'll say... Scott says it was a good stream. We played some variant Sudoku and poked at the music-based IoT project. That's awesome. Welcome to the Nova Show. Have you been here before, Scott, or are you just rating people randomly? How did you find out about the show? The socket state saturation. A socket state saturation from the procnet Unix file is the vast majority. 90% or higher in state 01. What is 01 again? 01 is SS unconnected. And we'll say single lines in the procnet Unix file indicating that a single Unix socket operates behind the socket file. This is to be expected as we call close for each connection. Okay, sounds good. We'll say Nginx will cool. So upstream server always returns, not accepting new connections. And then here's our third case. We'll say upstream server accepts new connections, but never calls read. In the case where the upstream server does call the C function accept, but never calls read or close on the file descriptor. Okay, y'all ready? Let's run it and see what we got. Ooh, interesting. So we're getting a lot of 2s. We're still not actually watching to see what Nginx does here. I guess the fact that we're seeing a lot of lines would indicate that there's a lot of open sockets, which would make sense because we've never called close on them. Interesting. But again, similarly, we have this, and let's just see. PS aux grep curl. Curl is hanging. We want to make sure we capture the hanging. Grab this one right away. Nginx will hang. Well, it's pretty much the same as this behavior. Multiple lines. Cool. File indicating multiple Unix sockets open on the same socket. Okay. Sorry, I just want to be super thorough here so we have good observations to base our work on. Because we're going to actually perform analysis on this when we get to the end. But we need data first. And so we're just collecting the data right now. This is like the worst part of being a scientist. It's like the boring, like you have to just go and do like all the chores and actually collect data. Okay, so Nginx will hang and curl clients will wait for a connection to be established, blah, blah, blah. Okay, and let's go check our work for any bugs. Accept not read Unix, accept not read Unix. And let's link that again at the make file. Okay. curl is timed out. Oh, wait a minute. We're getting socket state 3s now. Hold on. See, this is why we check this shit. This is why we check our shit. This is like, do y'all ever watch Lookner? Steve Lookner? Agenda Free TV? Do y'all know who I'm talking about? If you hang out in our Discord, this is like our news guy that we watch for news. It's like whenever he sees something, he's like, breaking news! And everybody's like, whoa! Breaking news! Right? And it's like very exciting. This is what I feel like when I just got here. All of this data is fucked. Delete all that. Thank you for the follow. So where are our run cases? Cool. So let's run our cases again. And this time we have to actually go make new observations. Our observations were flawed. Okay. 100 happy paths. 100 sad paths where we accepted but we did not read. And then now 100... sorry. We did 100 no accept. Now we're doing 100 accept but no read. Aha. There's a 1. There's a 3. Most of these, so we get a double 3. And we get a 1 right after a double 3. So we're actually getting to see the state of the socket. Fascinating. So we're getting multiple sockets in state 3. I feel like this is not very surprising now that I'm actually like connecting the dots. I don't feel like we're actually uncovering anything all too terribly exciting until we get into the Nginx part. Then we're going to start to see some interesting things. Okay, so let's finish our test. There we go. Okay, so let's record our observations now. Okay. Case. Upstream server accepts new connections but does not read. Here are the findings. Multiple lines in the procnet Unix file. The socket state saturation and state 03, which is SS connected. And we think Nginx is... We have to understand this line now. So let's go perform our test again. Happy no, or sad no accept, sad accept and hang, and let's look for curls. Yep, and so curl is hanging. Okay. Wait for a response. Cool. Upstream server accepts new connections but does not read. Okay, so let's save this research here. Cool, and we will I think that's it. So now let's do our final check here. So server accept not read Unix.c. So we'll copy you. Accept read not load. Do we want to separate read? I feel like if we're gonna read, we should write. It doesn't, like, at that point the socket's not really gonna change if we're reading or writing. We'll be thorough. Okay, we'll say server accept read not write.c. Okay. Make file. We gotta be thorough here. We gotta be thorough. I know it's boring, but we gotta do it. Server accept read not write. We have server accept read not write.c. Unix.c. Okay, there we go. And that's fine if the binaries are there. I don't really care. Okay. See, and we had to add that file. We'll remove the binaries when we get to the end. I'm cool with that. Okay. So let's add a case. Server create socket, call accept, call read, but does not call write. Server accept read not write Unix. And server not write Unix.c. So we just do read and we scan the buffer. So car method buffer size scanf method URI version. Yeah, I mean, I think this is really what we need to do, because this scanf just puts the request onto our buffer, which I don't even think we do anything with our buffer. Car method buffer size URI version. Right response. See, and we don't even do anything with this. Like, I guess we used to just print the data. We don't need to do this. Okay. So we'll copy this. And see. Read the socket. Do not write. We'll say no longer write. Great. Okay, so no curls. Let's run our tests, shall we? Where are you at? There you go. 100 happy requests. Does not accept. Does not read. And then this is our new results. It looks pretty much the same as the previous one, which is to be expected. Except, oh, we are getting, we'll say the latency from does not read. Case reads but does not write. Note. The output of the test indicates there is a small latency between when the socket state switches from O3 SS connected to O1 SS unconnected. That increases in this test case. During the duration between socket states, there is a sample where there is only a single line in the proc.net Nginx file. Presumably, this occurs when the curl times out. One, case 2, case 3, case 4. Cool. There's that one. So now let's do a read and a write, but not a close. Okay, create a C file, server accept, read, write, not close Unix. Oh my god. Make file. So how's everybody doing today? That's the question. How many of you are even here watching me still? I don't even really know if I'm streaming anymore. There's a good chance I'm just talking to myself at this point. Upstream. Looks like people are... something's moving. There we go. All the Lisas is still here. Awesome. Ditto, says Dan Holton. Awesome. It's cool to think about how many people are just at home chilling on a Sunday just watching me stream. For my first Rust project. Nice. Happy to know you're writing some Rust. We're big Rust advocates here. Cool, so there's this. Server create socket, call accept, call read. All right, but does not call close. Server accept, read, write. Not close. Oh my god, these names are getting ridiculous. I actually made popcorn. Nice. Cool. So let's make sure our implementation is correct. So we want to read, write, but not close. So make upstream. Okay. And run our cases. Let's get my docs ready before we run this. Readme. Here we go. Case 4. Case 5. Reads, writes, but does not close. In the case where the upstream server does call the C function accept, but never calls. Oh, we need to change this. Sorry, let me go audit these really quick. Okay. Upstream server. Here are the findings. In the case where the upstream server does call the C function accept, but never calls read or write on the connection or close. Okay. In the case where the upstream server calls the C function accept and read, but never calls write on the connection nor close. Okay, and then in the case where the upstream server calls the C function accept, read, write the connection, but never calls close on the file descriptor. Here are the findings. Okay, let's do it. Cool. So happy, no accept, no read, accept, read and write, no close. And then this is going to be interesting. Accept, read, write, no close. Cool. And then it looks like this latency has increased even further, to be expected. Okay. Cool. So and let's run our tests again. Happy, accept, no read. This is the one. We should see curls. We do. Curls continue to hang, and then we should be done with our tests. Curls continue to hang. Curls are closed. Okay. Very good. Great. So this next one's going to be fascinating. Let's see what we get here. So we can synthesize waiting and see what the socket states are in. Well, I guess at this point we're pretty much done, because once we implement this last one, we're back to square one, right? We're back to just returning 200. Okay, so let me save this. Okay, cool. Okay, so there's that. Okay. So we'll go edit this thing in GitHub later directly. We can close this. And I think that's pretty much the state of affairs. I think that let's get this cleaned up. I think we're pretty much, I don't want to say we're done. We're just kind of done with this first initial bit, and then we're going to add more to the project as we move forward. Okay, so let's turn off dark mode and let's edit this thing directly in GitHub. So we need to update our runtime condition. Let's edit our findings here. Okay, so this is going to get a little hard for you folks at home to follow along with, but I trust you're going to be okay with this. We're going to have to zoom out. I'm sorry. I know, it's so small. I know. Just bear with me. I just got to update my stupid table here. Oh, this table is very obnoxious. Mm-hmm. Cool. So this is our no socket file. Cool. So we have stream dropped again on my end, says Arjun. Sorry, Arjun. I think it's my internet today. Sorry about that, folks. Looks like we're back though, right? Cool. I'm also having issues with chat, so it may be them, says Virgin. Yeah, Twitch likes to do things on Sunday. Okay. So the question here is, where in Nginx will we be able to see? I have audio but no video, says Buchamera. Interesting. This sounds like Twitch. This has got to be a Twitch thing. I had to refresh to get the stream back. It's got to be a Twitch thing, you guys. Something's got to be going on with Twitch. Yes, refresh cleared it right up. So now what I want to get... Let's run this again and let's look at our little dashboard here. Okay. So here's our first test case. So we have 100 requests. They're all HTTP whatever. And then we press any key to continue. And we really don't see any more requests here, right? Because we're not completing anything. $400. Interesting. I guess it's because the backend server closed, and so Nginx, I guess, returned like a 500 or something because the server went away. Let's go see. Can we get the request visitor host names and IPs? Is there not a breakdown by like 500s or whatever? 500 server errors is 300. It's 200 success. There you go. Cool. Let's get that into our research as well. Findings. And there we go. Image.png is fine. That's fine. We'll say Nginx. Of internal sockets opened up via a single socket file on the file system. There are subject to be multiple sockets per file. Socket instances. File descriptors exist for every connection that calls accept. Okay, so I believe accept returns a file descriptor. Let's go check and see. Yes, new sock file descriptor, of course. Of course it does. Readme.md. Okay, I'm finding the Unix socket states are indicative of the internal sockets opened up by a single socket file. There are subject to be multiple sockets. Socket file descriptors exist for every connection. Where the upstream server calls accept. In the event that the upstream server does not return a a 500 level internal server error. Upstream server always returns HTTP 200. Do. Okay, so here's our write-up. We'll have to write some more of this up. I'll do that tomorrow morning when my brain's fresh. Okay. So now what we want to do is we want to see if we can get any data out of Nginx on what's actually going on at the Nginx level. Let's save our work here. Cool, so there is that. Work has been saved. And let's now go view it in GitHub. Oh, and looks like run the proxy. Hold on. Here we go. Cool. Who forked this? That's what I want to know. Somebody did. Let's go see who forked it. Cool, somebody forked it 39 minutes ago. Cool. Upstream server not accepting connections. Helps to inspire you to improve your coding skills. I'm not really doing any coding right now. I'm doing fucking boring research, which is cool. Like, I mean, it's nice to know I'm at the point in my life where I'm performing computer research, but like, I don't know if it's like, you know, I'm not doing anything very exciting right now. None of the cool stuff that y'all have seen me do in the past, back in the olden days. Okay, so here is our server. Let's start talking about Nginx metrics now. So option 1, we can try to get Grafana up and installed. Let's see what we have in production here. So this is the Hackaderm dashboard, which one of our beautiful nerd members, DMA, has set up for us. And so I believe we can go to browse. See, there is an Nginx dashboard here. So we can see response size, counts, response time, average response time. This isn't giving us any sort of like indicators though of like requests at Nginx, like how many current requests it has. Frankly, I don't know if we're gonna get it. One second. 1 second. Mm-hmm. Just reading some stuff right now. Don't mind me. Okay, cool. Okay. So let's talk about Nginx. See active connections. So we can do Nginx status here. Handled requests. So do we have Nginx status already enabled? Let's go see. I think we do. In which case we can just curl and get this the same way we do everything else with traffic. In fact, let me go make a coffee and we'll do that really quick. We'll get the metrics from the endpoint there. I'll be right back. let's write some Nginx stat scraping. What do y'all think? Let's do it. And thank you for the follow, everyone. I do appreciate it. If you're new here, tell us how you showed up here and why you followed. Introduce yourself. We would love to hear from you. I know I can be super focused. I guess that's why people follow, is they just like the music and the focus, but also safe to kick off conversations as well. I love you all very much. And most of the people here can tell you where to go to get ahead, if that makes sense. Okay. We worked together, says Mittens the Killer Bunny. I like my anonymity, though. Interesting. Okay. Let's see. So we want to intercept. We want to intercept this traffic sample. In this case, we running on port 80. Or so let's see what we have for our Nginx status in point here. So Nginx conf stats, stub status. Cool. We also check the Nginx status. Module serving metrics on slash stats, right? So let's run our proxy and okay, starting Nginx reverse proxy, and I think we can basically do localhost 80/stats. Here you go. Okay, and so now we should be able to curl silent this. Cool. And so we'll basically run this command. Okay, let's run our test now and see what we get. Sudo eps aux grep curl. Hey. Sudo e run cases. Let's do it. Oh. There we go. Okay. Cool. Server accepts handled requests. Perfect. Cool. Active connections 101. Interesting. So active connections is probably our best way of determining. We should see this go up to 300. Cool. Press any key to continue. Let's actually do this really quick. We'll just do 10. Let's try this again with 10. I'm just curious what we see here. So active connections 1, we responded 12 times. So active connections 1. Active connections 11, active connections 11, 48, 49, 60, and we're done. Okay. So sending... Thank you for the follow. Okay, so we'll do 100. Let me do this really quick. Let's run cases. Actually, let's do this. We'll do source upstream, accept not read, accept. Cool. So accept not read. And so then we want to curl localhost 80. Oh, sudo e proxy. We can just build a one-off test really quick. Source Nginx sudo e proxy. Okay, and then we need a third terminal. Sorry, I just gotta do this really quick. Why is it in my brain? Curl localhost 80, and it hanks. Kick off a bunch of those, and then curl localhost 80/stats. Active connections 14. Okay, the upstream is proxy is not actually accepting. Active connections 27. Perfect. That's huge. the active connections metric from where's the Nginx? What was it? Nginx stub status module here. Which client connections currently waiting on the upstream server? In order to demonstrate the buffered requests, perform the following steps. 1. We'll say 1. We'll say start and Nginx reverse proxy using proxy 2. Start a start a bad upstream server. Source, what did we call these? Upstream server accept, upstream server not accept. Send requests to the proxy server. Read the output of the status module. That the number of active connections represents the number of requests which are currently hanging and waiting for the upstream server to accept. Plus 1. Cool. So that's plus 1. Cool. I mean, that's pretty straightforward, right? Now let's do... Oh, and so we finally get gateway timeouts. Beautiful. We'll return 504 gateway timeout. There you go. So there's that. So now let's post some big data. Curl send large post request. Let's actually DOS this thing. What do y'all think? Cool. So we have our proxy server. And we have this. So let's htop. And then I think we can F3 Nginx. There we go. And we want to see our memory is 0, 0. Okay. So let's create a big file. How do we want to do this? Findings, and we'll say another memory check. Do Nginx metrics. Nginx memory consumption. Check to see how Nginx responds to large requests with a faulty upstream server. First, create a large file for as a bogus payload. Byte size is 1 meg, count is equal to 4. Okay. So we'll actually run this. Count is equal 1024. So 1024 megs is how big? We'll say 16 megs. There we go, 16 megs. Create a 17 megabyte file. And let's now send a big post request. So this will be curl, what is it? Curl x post data is equal to temp payload.dat. Local host 80. Add requests. Why is that a bad request? At var log Nginx proxy analysis error log. Let's see. Connection timed out while reading response header. Upstream timed out. Connection reset by peer. Yeah, this is all indicative of it, but why are we getting a 400 when we try to... Let's try to just do a post without a payload. Okay. So why is... There's an Nginx reverse proxy. Let's do a sudo. What do we have here? We have upstream basic server Unix. Here's a good server. Our proxy is still there. We're still getting a bad request. Curl local host on port 80. Yeah, so, and then if we do a curl x post, why would this... Oh, is it because it needs to be all caps? There, that's why. Herpy derpy Nova Pants, come on. The old curl needs to be all caps. This old bit again. Okay, so start a bad server. Run our proxy. And run our big post request. With correct posts. That should hang. We're gonna need a third terminal, a fourth terminal. We have 3 requests here. Let me close all this stuff. Hold on. Sorry, I really have to go see what's going on inside Nginx. We have to like build very specific conditions here. Okay. Pop. So how do we only see a specific process in each top? So we can filter F4 for Nginx. There we go. Okay. No memory in Nginx. Memory percentage. And I guess we want to say we can do niceness. Filter tree sort by. I guess F2 setup. Header layout. Meters. Display options. Show kernel threads. Tree view. Colors, screens, active columns. So we have percent memory. What do we want? We want percent mem, tgid, vpid, rcar, rbytes, vbytes, io read, io write, cgroup, io priority. Base name of BDXC. This is all just proc goo. Out of memory. Yeah. We'll add out of memory. Okay. Cool. There we go. See over here, this 666 column. This is what we're interested in. Let's start to abuse Nginx. Okay, and we will run you in the background. Nginx reverse proxy. Still not seeing any uptick in memory usage here. It would appear that Nginx is not allocating memory for each request. It would appear that Nginx is not allocating memory per each request. Poor Nginx. I know, poor Nginx. Okay. Yeah, I'm not seeing... I see 12.1 gigs in total system memory, but I'm not seeing any uptick here. These are remaining relatively unchanged. In fact, we can say PID is this first one, 273,229. Yeah, and these are all timing out. Will not... on upstream server. Next, send large amounts of bogus post requests in a known faulty upstream server. Okay, so proxy and source, what did we say for the first one? Indicative. Cool. So where was our source? I feel like I just typed this somewhere. Source. Here you go. With a large payload. Hey, Theo, how's it going? So let's get our curl command. Next, in large amounts of bogus post request to the server with a large payload. Memory consumption of the main Nginx process and subsequent nested worker processes remains constant. That can't be by mistake. There's no way that can be by mistake. There's mem usage UI. Memory profiler works. We can do a memory profiler. Each top. What's a good command line memory profiler? So there's memory profiler for PyPy. Let's find a better one. There's new plots. Let's see. I wonder if there's like a gnome thing we can use. Yes, there's PMAP. I want to see a graph over time though. There's got to be like a memory. Like Linux desktop memory graph. Let's see. How to visualize memory. There's SMEM. Here we go. User Alice. Used ByteHound in the past. ByteHound? See what ByteHound looks like. Stacer. Let's see what Stacer does. And we're building Rust. Well, I'll be right back. Oh, good. My install Stacer created a go error. Got it. Great, great. So there's the GNOME system monitor. There's bash top. H-top. I only want to see like a single... There's bpi top as well. So this... Can we... How do we filter? Right. I guess you go here and you can do... You'll see Nginx in here. See Java. I need to start typing. Oh, I see. There's 4. Oh, that's process. Okay, I see. So there's 1, 2. Ooh. Ooh. I actually like this. Let's look over here for Nginx. How do I filter? Let's go to the top. Yeah, Nginx is running, and our bad server is also running. So, the Rust compiler. How do we filter, though? Let's see, bpi top filter. Oh, filter Nginx. There we go. Okay, so memory. Here we go. So terminate Nginx memory CPU, and then we can turn that on and off, and we can turn network on and off. And we can CPU responsive, PID, program, arguments, threads, user, memory. Okay. So now let's... Nothing. Absolutely nothing. Threads 1, user root, parent proxy. A lot going on right now. So let's try something really quick at nginx.conf, and if we come here to this, and let's just change all of our 4s to 48s. And go back to bpytop. Now we have 6 and 3. It really doesn't allocate any fucking memory. Interesting. So let's try... We'll stop Nginx, and we're gonna actually start a proper server and see if it allocates memory. Y'all with me? Sudo source upstream server Unix. Basic server Unix. Okay. Run our proxy. And now it should be responding, right? So like we should be able to actually send one and it should process it. And so the question is, do we see its memory usage go up here? Right? So let's... No. Oh, status dead. That's why. Let's see. Status sleeping. So let's go back. Close is return. And let's look for a proxy and see if it's just getting allocated to a different... Sudo proxy nginx. Okay, so let's just look here and see if we see anything. No? It went up to 4 megs. I mean, but we're sending fucking 17 megabyte requests. And I guess, like, really our C server would have to allocate memory. In theory, Nginx could just be doing this over, like, a very lightweight, like, ring buffer style. I don't know the internals of Nginx well enough to know. Who here knows Nginx internally? Who here knows if Nginx will allocate memory if the post request? I bet we could Google this. Will Nginx allocate memory for large requests? Nginx's memory allocation. Here's a Medium article. Let's see if this jives with what we're seeing. Implemented its own memory allocation. Its memory allocation is in Nginx p-alloc-c. It works in the following ways. How open rusting Nginx. I pretend to know Nginx on my CV. We should all be ashamed of ourselves. If anybody here has Nginx on their resume and they don't know the answer to this question, you are a perfectly normal engineer. So let's go and let's see here. Works the way when Nginx wants to allocate memory. C memory allocator. So it's Nginx p-alloc.c. So let's do Nginx source code. Source. Core. p-alloc.c. Create pool size. I haven't touched it yet. Mittens the Killer Bunny, who are you? You're taking just a few kilobytes of overhead per active connection. If you're using something like Apache, you'll have one thread per connection, which means hundreds of kilobytes. Nginx is not async on disk. Interesting. It looks like it's just a few kilobytes per disk. Keeps growing during load. That's in memory leak. Nginx consumes much more memory than expected. Virtual memory. There's cleanup file, delete file. There's create pool. Mem align. Destroy pool. Reset pool. Palloc. Nginx Palloc pool small. What is, I guess it's process allocation? Interesting. Oh, you can chunk out blocks? Oh, that's got to be an internal function for how they actually manage the pool. P mem align. Large pool. Small. Alloc is equal to P. Next pool. Yeah, this is just like a basic memory pool. Okay, nothing exciting there. Thank you for the follow, Nico Zika. Let's see what we expose. Page size. Yeah, there's p-alloc. Thank you for the follow, Blue Spider. Okay. Rate limiting. Your connection. Uses one file descriptor. This looks... Here we go. Tuning your Linux configuration. The backlog queue. The following settings relate to connections and how they're queued. If you have high rate of incoming connections, you're getting uneven levels of performance, then changing these settings can help. The maximum number of connections that can be queued for acceptance by Nginx. The default is often very low. Oh, so can we set this to... What does SO stand for? Shared object, I guess. The rate at which packets are buffered by the network card being handed to and from the CPU. File descriptors. Worker processes. Keep alive connections. Caching. I think you have to change this with sysctl, don't you? Let's go see. So I think we can basically do sysctl. Let's do this. Cat rock this net or SomaxCon 4096. How can I do... This might break my computer, y'all, so if I drop my stream, I'll be back in just a second. 3, 2, 1, running. Permission denied. You can't write it that way. You have to use sysctl. Okay. So I think we do sudo sysctl w net core SomaxCon. We'll do 12. We'll do 8. We'll do 8. There it is. You recreate within 90 seconds. Okay, cool. I said that on stream before. Okay, so let's... Our reverse proxy is there. Let's go and let's send some large payloads. I doubt we're gonna actually get above 8. There's no way we're gonna go faster than the computer here. Let's see. All stays constant. And let's put this now. That's still 8, still constant there. And let's send some traffic. PS aux grab curl. There we go. And Nginx looks fine. Proxy is serving here, and let's curl localhost 80 stats. Active connections 27. And then let's cat proc, what was it? Prox cat proxys net core so maxcon. Let me capture that. The amount of, what did we say? Active connections. Sorry, let me set this back before I forget. Or what was it before? What is, hey Google, what is 248 times 2?
248 times 2 is 496.
Here we go. Okay, so maxcon, first set, maxcon. The cloud is just someone else's computer. The amount of active connections does not appear to be limited by the maxcon kernel parameter. First set to a small number. Next start the proxy and a bad upstream server. Which we seem to be doing a lot of, which is good. It shows we wrote good tools. Next start the proxy and a bad upstream server. Send create a large number of requests to the server, to the proxy, dash, and we had, what did we do? Where's our curl x post? Bash. Here we go. Check in check. Cool. So that's Somax Con, but it still looks like Nginx has fabulous memory allocation. I'm gonna go ahead and say the backlog queue. And let's hold on, let's do some resources here. Connections and how they are acute. If you have a high rate of incoming connections and you are getting uneven levels of performance, these settings can help. The maximum number of connections that can be queued for acceptance by Nginx is usually because Nginx accepts connections very quickly, but can it be worth increasing? Yeah. Uses one file descriptor for the client connection and another for the connection to the proxied server. File descriptors, I see. Queued for acceptance by Nginx. So I think what this is saying the Somax Con parameter is useful for connections where be queued for acceptance by Nginx. Which will only impact the proxy server when the upstream is working faster, is working more efficiently than the proxy, right? Queued for acceptance. So Nginx has to call accept. The accept implementation in glib. So this would allude to the accept implementation in glibc having a queue. Let's go find out. Let's go actually look and be sure. Where is glibc accept? Accept to include assist socket.h. Let's go look here. Where's my C server? Accept not read. Here we go. Await a connection on a file descriptor. When a connection arrives, open a new socket to communicate it with. Set adder. If use GNU except for. End F. Extern shutdown. This is the header. What file is this? This is syssocket.h we said? Yeah, syssocket. Let's go find syssocket.c. Where are you at? Linux syssocket.c. Syssocket.h. This is netsocket. And we want to go to, we said 6.2. And we want to find except for. Here we go. New file descriptor. For except we attempt to create a new socket, set up the link with the client, wake up the client, then return the new connection file descriptor. We collect the address to the connector in the kernel space and move it to the user at the very end. This is uncleed because we open the socket, then return an error. This new feature, ability to do received message, sys except for, file descriptor get. I don't think file descriptor get in the kernel will actually do any queuing. Will it? Sock from file, return null. No, it does not. It does not do any queuing. Whoa. Where was except for? New get unused file descriptor flags. There's do accept. Sock from file. We don't need to try module get here. Sock allocate file. Sock accept. Let's check for maxcon. Here we go. So this is listen. Perform a listen. Basically, we allow the protocol to do anything necessary for a listen. So maxcon is only relevant in the sys listen. This is why y'all need to go read the fucking code. Where's our readme? Only impacts the listen function as expressed in the socket implementation. When the upstream is only working more efficiently than the proxy, as the Nginx process will call accept. Let's go look at our code. Hold on, let me close some of this stuff really quick. So we call listen. Oh, do you pass maxcon into listen? Interesting. Here we go. Listen, in connection, requests will be queued before further requests are refused, according to maxcon. And this is in which file? This has got to be syssock.h. Yeah. Little syssoc.h, I tell ya. This file, syssoc.h, has popped up in my life, in my career, more than any other fucking file in the kernel. This is the #1 file that just year after year, relentlessly, no matter what goofy shit I'm working on, the syssocket.h is like just fucking haunting me. Yeah, okay. If the upstream is working more efficiently than the proxy. Prepare to accept connections on a socket file descriptor. So we can call listen, and then we can Nomax con. Requests against a server calling listen will be queued before refused based on the in which will own. This is where I want to make sure this statement is right. This is I'm getting into analysis territory here. I don't want to necessarily do analysis yet. The maximum number of connections that can be queued for acceptance by Nginx, which will only impact the proxy server when the upstream. No, this is wrong. Which will only impact the proxy server when the upstream is working more efficiently than. And we know that because we were able to demonstrate that Nginx will proxy connections granularly based on the behavior of the upstream server. So in other words, here's the question, right? If the upstream server has called accept, does Nginx call accept? I actually think Nginx will call accept for every connection based off of SOMAXCon. I see. Syntax checks new. Or that it is. Nginx will accept connections regardless of the state of the upstream server. will call listen. To requests in the event the upstream server is not calling accept on a request, Nginx will queue the request on a given request. Nginx will queue the request and eventually refuse a connection as the SOMAXCon threshold is crossed. Very good. In a large number of requests to the proxy. Check active connections 27. The SOMAXCon kernel configuration only applies to the listen function as expressed and here and defined in the code. Requests against the server calling listen will be queued before they are refused based on the value passed to the listen function. According to a popular Nginx tuning guide, the SOMAXCon is used to configure and match for acceptance by Nginx. The research shows that Nginx will first call listen with SOMAXCon and accept connections regardless of the state of the upstream server. In the event the upstream server is not calling accept on a given request, Nginx will queue the request and eventually refuse a connection as the SOMAX threshold is crossed. The value that SOMAXCon is set to is the value that SOMAXCon is set to can be reasoned as the effective accept queue for a given Nginx proxy pass directive. Okay. So requests against a server calling listen will be queued based on the value passed to the listen function according to a popular and accept connections regardless of the state of the upstream server. This is correct, yes. In the event the upstream a given request, Nginx will queue the request and eventually refuse a connection as SOMAXCon threshold is crossed. So where's my memory? Didn't I put memory, Nginx memory consumption? Ah, here we go. I want to move this. Locate memory in the event that a request is queued. First, create a large file to serve as a bogus payload. Next, start the Nginx proxy and a known faulty upstream server. Send large amounts of bogus post requests to the server. Memory consumption remains constant. And then we want to reference the Palak implementation as our supporting argument here, which is here in palak.c. Remains constant. Gat Noob says Nova. An easy way to make sure Nginx doesn't allocate new memory would be to trace and make sure it doesn't. You Gat Noob, you are. I love you sometimes. Okay. Where's my proxy? Proxy. So what's our strace? strace p this pipe to grep dash I alloc. Okay, so let's put where's, hold on, I got a lot going on here. let me close b pipe top. Exit out of this one. Okay, so this is active connections 1. Server accept not read. So we want to do upstream server not accept Unix. Okay. And let's do a curl localhost 80. And then Somax con is set to 8, so we should be able to do 1, 2, 3, 4, 5, 6, 7. Oh no, I set it to something else, didn't I? I'm not seeing any mallocs. And then is there a curl D? Cool. It looks like it only called malloc at the beginning. And where's our big post command? Let's grab that out of the readme. Out of our readme. Where's that big ass post command? I'm gonna eventually time out. And let's This would also imply that, well, let's restart our proxy. Ooh. Interesting. So this is... Okay, here's our malloc. Here's our client. Client, no malloc. Client, no malloc. Client, no malloc. Client, bro. Oh my god. No malloc. Big client. No malloc. Big client. Oh my god, oh my god. PSOX grep curl. We're waiting. We're waiting. No malloc. No malloc. Do you need to establish that the memory usage on the constant is on Saturday? Makes sense of there are no new mallocs, I guess. Yeah, we're just checking. strace F to follow forks. Let's do it. Cool, and let's... Nothing. We get a lot when it starts, right? We do e-polls, we set UIDs. I don't know why. I'm doing a grep-i for malloc, I think. What am I doing? Grep-i for alloc, A-L-L-O-C. Is that... It does, yeah. Nginx has its own memory manager, which is what we just called out. Okay, so wait, here we go. So there was one. Let's try this again. So let's see. This is what we get if we do -F. So we have an epoll. So here we have a local host, ioctl socket, sockstream, epoll wait, write ev, get socket option connect, epoll socket, epoll control, receive from, epoll wait, accept. I don't see a malloc in here, y'all. There's got to be an alloc somewhere in here that we're missing, maybe? Or my grep isn't working. I mean, we can... This is a single request. Your libs, yeah, I'm not grepping for anything here, Gat Noob. This is all the syscalls for Nginx and all of its children. That's it for a given request. That's everything. I ain't seeing, I ain't shook. I ain't seen no mallocs up in there. Yeah, no malloc confirmed. Where's our proxy? And so the only other thing I would want to do is we sent 12 of these, and I'm still seeing accepts, honestly. Yeah, it'll still call accept. It'll call connect. So this is fascinating. Nginx does call connect after it calls accept for. But, hey, don't know much about syscall, but doesn't malloc send immap and bork syscalls instead of alloc? Yes, Miraz, which is... We had seen one in here. Here. epoll. Epoll is how it's queuing. Anybody who's worked on Docker can tell you that. Get sock ops connect. And then we're now writing gateway timeouts. Yeah. And it'll close the connection after every Nginx synchronous. We'll say Nginx proxy behavior. Proxy paths defined in a configuration. For every client request, Nginx can be expected to perform the following. Call accept. Really, SOMAXCon is only for listen. That's fascinating. Call accept for each client request. Innova, hey chat. Yep. Also, Nginx writes level 3 log message when it requires new memory and uses not malloc. And uses POSIX memoline, not malloc. Thanks, cat noob. I mean, we would have seen any of that in the strays. Which I'll write up now. Nginx can be expected to perform the following. Call accept for every client request. on the proxy socket. Call connect against the upstream server, right? Let's go back and find it. Yes, here. I'll close the upstream close. Or the request comes out. Right, so we're getting close, 25, close 22. Are we sending 500s here at this point? Yeah. In the event a cool. For every client request, Nginx can be expected to perform the following, except synchronous write against the upstream server. Cool. Test cases and observations, and then there we go. Cool. And then we will say, where's our memory write up? Let's add our strays here. And where's our Somax con? This is the, actually, let's finish the memory one first. Memory, and view the output of a given single post request. What was our finding? Okay. Cool. And this was of active connections returned by this will not be limited by as the active connections will take upstream connections into consideration. The Somax con kernel value only impacts the proxy server following listen for new clients. Hmm. The research shows that Nginx will first call listen with SOMAXCon and accepts new connections regardless of the state of the upstream server. Correct. In the event the upstream server is not calling accept on a given request, Nginx will queue the request and eventually refuse a connection as the SOMAXCon threshold is crossed. Correct. Accept queue. Pass directive. Note. Nginx will also timeout requests by default, which have behavior almost indistinguishable from queue thresholds being crossed. Except for I'm assuming, let's see, it'll still return a 504. Actually, no, because we haven't tested that. I can't put that in there. Okay. That looks good. Nginx memory consumption, and then here's our test cases. Cool. I think let's save this and take a look at it. What do y'all think? Get status, get add. Get add source to get status. And our readme. Save. Let's go see how this looks in GitHub. GitHub.com/ what was it? Chris Nova / Nginx proxy analysis. Test cases and observations. And didn't we add a second engine? Yeah. Remains constant. For implementation detail of a single post request. Cool. So this is, I mean, this is just good research to reference, which will be helpful. And I want to now edit, go up to the top. What others have an impact on Nginx failures? What is the due to upstream socket conditions? There you go. Cool. So that looks good. And then I think really the only other big outstanding question in my mind at this point, no, I got to think about all the implications of all this, is any other Nginx configuration that we would want to test just to exercise and see if it introduces any obscure behavior. Does Nginx have a locate memory malloc bool that you can go define in nginx.conf and just completely changes the whole behavior of everything, right? We would want to go and exercise that, but given our current config, I think this is reasonable. Also, another thing to bear in mind, we didn't really look at any of the Nginx logs, which is indicative of good research, but the actual behavior to the client is it's going to be doing all kinds of crazy stuff. Connection refused. There's just all kinds of stuff that could go on there. Anyway, I'm going to wrap up for the day, and we're going to raid a good friend of mine And I'm going to call it a day. I'm going to go upstairs and see my family. What do y'all think? Should we wrap up? Let's wrap up. Let's fucking do it. So who here has been hanging out during the stream and has not said hello yet? You have to come and say hello to us here at the very end. Gatnoob says underscore time, and that is absolutely correct. Thanks for stream, as always. Thanks for research. Sure. Who? I don't know why anybody would be interested in this research, but it's here now in case you want to see it. Karo says hello. Bocamera says thanks for teaching. Algobro says have a wonderful evening. Yeah, I don't know how valuable my research will be, but hopefully it helps out. So nice to see you. Hi and goodbye, says Tattooed. Okay, cool. So who here wants to tell us what we do to Zunderscore when we raid Zunderscore? The process is fascinating, says Maddock. Who here wants to tell us what we do to Zunder when we raid Zunder? We're going to be adding all the emojis. Our goal is to fill the whole side of his thing with emojis, and we try to DDoS his stream with activity. His OBS will like say things, it'll play music, his screen will flicker, like all kinds of stuff happens. Gatnoob says spam eggplant emojis. Gatnoob is 100% correct. So get into all of this. Yes, I graduated from MIT. I'm an MIT grad. I'm one of those people. Anyway, we will see you all next time. And there you go. Thanks everyone. Have a great day. Talk to you later. We'll see you next time. Bye.